Today, I want to experiment a bit more with local AI models and specifically see if they can run my autonomous AI pipeline. This is going to be unscripted. I actually haven't tested this yet, so we'll show all the rough edges and everything. And it's entirely possible that this is going to go nowhere. So let's see. But my last local AI experiment was pretty promising. So I'm cautiously optimistic for this one. Hi, I'm Mirko. I run GammaVibe, my AI lab where I experiment with all sorts of things, including local AI. And here is one of those experiments. Late last year, I had this idea to see if I could automatically generate startup ideas based on news signals. So I built this pipeline to basically prove this hypothesis, and it actually worked really well. You can see the results at GammaVibe.com. Here's an example of what this looks like. Just take a look at your leisure. I've walked through this many times, and you're probably tired of me doing that. But it basically presents a startup idea and a full business model and tech stack. And then I later published a course that teaches agentic engineering and uses this pipeline as an example so you can build your own. That course is now free on YouTube. Maybe you've stumbled across this already. And there's also an accompanying GitHub repo right here. That's actually the full source code that I generated while recording the course using Claude Code. And this is actually the code base that I'm going to be using for my experiment now. That's why I'm showing this, right? So my real production pipeline essentially looks the same. It uses all the same steps, but it's fully productionized. It uses PostgreSQL and pgvector. It runs using Docker on a VPS and publishes to my Ghost newsletter and all of that. And my slightly simplified pipeline that we're building in the course uses a local SQLite database. It uses ChromaDB and things like that. But otherwise, it works the same way. So my pipeline has this AI models class. And previously, the only supported AI provider was Google Gemini. And I had this provider config here that specifies the different models to use for each stage of the pipeline. I recently updated this when Google released some new models. So I'm using Gemini 3.6 Flash by default. I actually found that the newer Flash model works just as well as the older Pro model that I was using in the course. So that's kind of the default now that I use for the steps that require a bit more reasoning. Then I use this really old Gemini 2.5 Flash Lite model for the triage step that just looks at a news article to see if it's likely to have some relevant signals. Doesn't need much reasoning or anything like that. It's important that it's fast. For extraction, I use Gemini 3.5 Flash Lite. And then there's image models and things like that. Anyway, I just used Claude to abstract this out a bit more into different provider configs. So now I have the Google one. And then I have this one, which is still untested. So I'm going to use LM Studio. I'll actually show this in a second. And in LM Studio, I'm going to use two models. The reason I only use two is because I actually can't keep all of them in my GPU's VRAM at the same time. And I wanted to avoid having to load and unload models dynamically because of the performance hit. So we'll see if this works. I don't know. But I'm basically using the open source Google Gemma 4 model in both cases. And specifically, I use the 12B QAT version. QAT stands for quantization aware. That's a variant that actually gives us essentially more bang for the buck. And then I use the slightly lower end E4B version for all the other steps, so triage and extraction. I could probably get away with something like the E2B version for triage, but again, I don't really have enough VRAM to keep them all in there. Not going to look at the implementation here in more detail. So here we see LM Studio. I have my local server running, and I have both of these models loaded. You can see I increased the context length a bit from the default. These might be parameters that I need to play with to dial it in. I mean, higher is more powerful, of course, right? A bigger context might be helpful for some of the bigger tasks. For example, our synthesis step, where we need to pass a whole bunch of business signals in and then have it creatively come up with some ideas. So we'll see if this is enough. It's certainly much lower than the context that the Gemini API provides or any of the other AI providers. But let's see. I have the lower end model at like 62,000 and the 12B one at 110,000. So I just kind of, roughly dialed it in. So we'll see if this works. I'm actually going to need this IP. So I'm running this on Windows, but I'm actually running my pipeline in WSL2, so the Windows subsystem for Linux. So I actually need to use the computer's external IP address here instead of localhost. I can also quickly show Task Manager here, just so you see that my GPU is actually loaded full of AI models, right? So here on the Performance tab, GPU, I have 24 gigs available. So this is my NVIDIA 4090. So it's basically full at this point. All right, so back to the IDE. So I implemented this change. Let's see if it works. So what I need to do is pass in the IP address, or rather the base URL. And then it implemented this new provider parameter. If this works, I'll actually push it up to GitHub as well, so you can play with it there. All right, so in theory, this should work, and it should use the existing loaded models. All right, let's try this actually. So I have Task Manager running on the right here, and then I'm going to kick off this command. So we should be able to see the GPU actually doing some work there. And again, chances are that it might fail. We might need to do some tuning about how we handle tool calling, or more generally, how we invoke the model. That's the kind of thing that needs some dialing in with these local models. So we did our fetch. That's where we fetch new articles from the news API. We got 43 new ones. Now it's running the triage. So that's where we batch things up. And then we got our first failure already. Request timed out. Interesting. Oh, I think I see the problem. I just forgot to append the port here. So it's port 1234. In fact, we can try this here in a new terminal. I think it's v1/models. That should return the models that we have. So this is all working. So let's try this again. Nice thing about the pipeline is that it's database state-based. So we don't have to redo everything. It'll try fetching, but it'll then see that it's all duplicates. And then it'll just process everything that hasn't been triaged yet. Okay, well, we got a different error now. Oh, it's another user error. I'm just missing the v1 suffix. Okay, it's realizing that I'm prone to making these kinds of mistakes. So it's now making it even more robust by adding a pre-flight check, so it fails without having to actually attempt to call the model. So just user error so far. All right, so let's kick this off. So I'm going to be hitting LM Studio at my local IP address, port 1234, and then v1 for the path. So we're fetching the news. We found one new article since we just ran it. So the delta is small, but there should be a bunch of articles that are still pending triage. So now it's actually hitting the local model. You can see the GPU is spiking here, right? So it's actually doing stuff. Hopefully this will work. The tool calling can sometimes be a bit flaky with these models. And there's a couple different ways to configure it with Pydantic AI, which is what I'm using. So if one approach doesn't work, there's a couple others. You can basically just ask it to return JSON instead of using tool calling. But actually, this seems to have worked quite well, actually. So it triaged 49 articles, kept 27, and discarded 22. So roughly 50% is what I'm usually seeing, is what we keep. And then the other 50% we throw away. So that actually looks promising so far. So now we're running extraction. That definitely is a bit more involved, right? So that's where we analyze each article. I think we look at the first 3,000 characters or something like that. to see if it contains any business signals or market facts, and then we extract those and store them in the database. GPU is still busy doing stuff. I can hear my computer fans humming here. Hopefully won't come through too noisily in the recording. It's definitely taking a moment, but so far at least it hasn't failed yet. So that's promising. And triage and extraction are my the two biggest steps in a way. They actually run in batches, and they're already doing parallel processing, where we run multiple batches in parallel. Claude was smart enough to tune that a little bit when it implemented the LM Studio provider. So we're running much fewer batches in parallel than we are with Gemini, just because our hardware is more limited. And then the next couple of steps, they're going to use the stronger Gemma 412B model. And that's going to be a bit slower, but those steps are also going to just run one prompt at a time. There's no batching that's happening there. Okay, extraction finished successfully. So it had 64 articles to process. That's because we had attempted to run the pipeline a few times. I initially had some syntax errors. So we had multiple articles queued up to triage, and then even more for the extraction phase. So we got 109 business signals and 49 market facts. So that's actually promising as well. That's roughly what I usually see. So now in the synthesis step, it's feeding essentially all of these signals. So it uses a multi-day rolling window. Okay, there we got an error. It looks like synthesis actually succeeded though, and it got to the deep dive. So let's take a quick peek here. So yeah, what I was about to say, in the synthesis step, we take all of these signals from the last couple of days. I forgot what the exact cutoff is here in the course version of the pipeline. And then we feed that into a fairly long prompt and tell it to look for patterns, right? Cluster things, and then come up with 3 distinct business ideas, one for each archetype. So one meta trend, one friction point, and one rabbit hole. The meta trend is off-balance sheet AI infrastructure management. Then we have clinical AI safety and audit verification as a friction point. And then for the rabbit hole, we have quant simulated perpetual swap education. I have no idea what that means. So it should have selected the friction point as the highest scored one. Oh, actually, we implemented the improved ranking as well, which I have in my production pipeline, which also takes into account similarity to previously published ideas and things like that. So after that, it ended up ranking the rabbit hole highest, right? We have the final score here. So, okay, what happened after that? So now it was supposed to run the deep dive. So that's where we take that idea and tell it to come up with a business model, figure out the tech stack and all of that. Okay, I think I know what this is. So the error is badly formed hexadecimal UUID string. It's probably an issue where the model kind of got lazy. So here is our database. Oh, this is the runs table, right? So every time we kick the pipeline off, that constitutes one run. So we had 4 failed runs in a row. This one completed the synthesis step. That's the last completed step. And then it failed after it selected a candidate. Okay, so we see that. Now let's look at the candidates table. Okay, so ours should be at the end, right? So there's the 3 new ones. The friction point is the one that it selected. Now let's look at the error again. Okay, badly formed hexadecimal UUID string. So our strings are here. At first glance, this actually looks right except for the dashes in the middle. So I wonder if it maybe returned a result with dashes and we were not expecting that. So it's a little bit of a slightly different error than I was expecting, but I feel like that's probably the problem. Do we have any sort of logging in LM Studio? I actually don't have that much experience with it yet. Oh, look at this. Okay, so let's scroll to the bottom here. then we should be able to see what it actually returned. All right. Candidates. No, I think that's the synthesis step. Yeah, here it returned the list of candidates, which is what the synthesis step produces, right? So we have a list, and then for each one, we have a dictionary that has the archetype, so meta trend. Then we have the theme, why now? And then here we have the next one, the friction point. Each one also has the supporting article IDs. Yeah, I'm not sure if I see what I'm looking for here. So let's do this. Just pass it into Claude Code. All right, so I'm going to say I'm running the pipeline with LM Studio and Gemma 4. It completed the synthesis step, but seems to have failed when it tried to run the deep dive. Please investigate. Output below. Let's use auto. See what we get here. It almost certainly has something to do with the format here. So while it's figuring this out, I can maybe talk briefly about what I encountered in my production pipeline. So in the triage step and the extraction step, I was initially passing article IDs, which can also be long UUIDs, into the model, and then relied on the model returning those. And the model sometimes cut off a digit or two. And that's when I was using the lower end model, for example, Gemini 2.5 Flash Lite. So I could have used the more expensive model. That's kind of unnecessarily expensive and slow. So instead, I mapped the articles to sequential numbers, passed those in, and had it return those in the response. So I could then map those back to article UUIDs. And that's working really well in production. And then for the later steps, when I deal with IDs, in production, I'm using either Gemini 3.5 Flash, or before I was using Gemini 2.5 Pro. So those are more sophisticated models that usually deal fine with, these long UUIDs without hallucinating or chopping anything off. But that might be the kind of thing that I'm bumping into here with my local pipeline, right? Because the Gemma 12b model, as solid as it is, isn't anywhere near as robust as the Gemini models. So actually, let's see what it says here, what Claude figured out. 3 separate problems, 1 crash. Oh boy. The crash itself parses the stored IDs with no validation, okay? Gemma wrote truncated IDs. Here's what synthesis actually stored for the 3 candidates. Okay, so apparently it stored these IDs, these truncated IDs. So those must be article IDs then. Why Gemma truncated them? Article inside is a UUID.UUID, so synthesis prompt renders article ID blah 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 dashed. Gemma copied only the first dash delimited group. It is not hallucinating. I checked all 7 truncated IDs against the articles table, and every one is an exact prefix of a real article. Well, that's good. The model picked the right articles and then abbreviated the identifier. Gemini copies 36 characters reliably. A 12b local model does not. Right, that is the kind of problem that I just talked about. Asking any model to transcribe UUIDs is the fragile part. The failure left inconsistent state, and resume will hide it. Okay. Load inputs commits its side effects before it parses the IDs. Mark selected, blah, blah, blah. Okay, so 3 different issues here. So if you run resume, deep dive restarts. Get unselected since now excludes the winner it already burned, and it will quietly proceed with number 2. Autonomous vehicle, that's fine. I would probably just kick it off from scratch. 3 changes in order of importance. Stop transcribing UUIDs, present articles to the synthesis agent as small integers. So that is exactly the workaround that I implemented for the batch step, which I use for triage and extraction. So we're basically saying do the same thing. I agree. I probably should just do that. Parse defensively anyway. Okay. Oh, and it's offering to repair the stored rows. That's a good idea, actually. Sure. Okay, so I'll tell it to implement all suggested fixes and also repair the stored rows like it offered. So apologies. I was hoping to just quickly play around with local models, but instead we're doing an impromptu agentic engineering exploration here. But the fix here is actually pretty straightforward. I just never needed it in my production pipeline with Gemini, but the pattern's there. And I'm cautiously optimistic that it'll actually work fine afterwards. And then the last thing to do is to actually just assess the quality of the generated result, because that's where I'm also expecting to maybe see some degradation from the production pipeline. Okay, it finished. So it implemented the suggested fix. So mainly we're not transcribing UUIDs anymore. Okay, and then it repaired the data. Oh, from the earlier runs as well. Okay. Okay, so I'm going to run it once. I'm going to use the resume parameter, which basically means it'll pick up after the last successful step. So it should resume with a deep dive. And then we'll finish this one, and then we'll do one more fresh one after that. But let's kick this off first. There we go. So it's starting with the deep dive. It has the ranking. So now it starts with this one here. So we see the model's working again. GPU is running hot. Well, not hot, but it's working. Okay, that was actually pretty quick. So the deep dive completed. It came up with the name PerpForge, a flight simulator for perpetual swap traders. It allows users to input specific assets, historical volatility, and funding rate assumptions to visualize how their positions will decay or accrue value over time. Traders pay for it to eliminate funding rate shock and optimize automated arbitrage strategies before deploying real capital. Okay, and then it completed the writer step. So that's where it actually turns this into a newsletter. Visualizer as well. And then the image generator, this is just going to use Gemini, as well as the podcast. Well, the script is going to be using the local model, but the actual podcast itself, the audio, will be using Gemini. Maybe I'll play with local models for this as well. I have actually played with some of the text-to-speech models, and there are some really, really good ones that run locally with fairly minimal resources. And, of course, image generation as well. So that could be a nice follow-up, perhaps. Yeah, and now it's doing the audio. So actually everything that Gemma is supposed to do is done. So we can maybe quickly just look at the outputs, see if they actually look reasonable. Okay, this is actually pretty terrible. Okay, so newsletter.md, that's the generated newsletter. It has the signal, it has the problem, and then it just kind of cuts off in the middle here. So it never really generated the full newsletter with all the deep dive and everything that's supposed to go in there. Okay, not good. I'm curious what the podcast script looks like. So this actually looks much more reasonable. It must have used the entire deep dive as input here, not just the newsletter markdown itself. Okay. Oh yeah, and the pipeline did finish. Okay. Let's quickly take a look in LM Studio. Yeah, that's the podcast step. So if we scroll up, that should be, oh, that's the image prompt. So the one above should be the writer step. So here it generated the subject line, preview text, okay, markdown content. And yeah, then it just kind of cuts off right here as we saw in the actual markdown. And this is the content that we passed in, I think. So maybe this is just a context issue. I'm going to come back and run another experiment later. I'm going to have to stop this one for now. All right, so I did a little bit more troubleshooting and debugging off camera, and the fix actually turned out to be surprisingly simple. It just had to do with the model settings in LM Studio. So let me actually briefly show the end result first, and then I'll show you what I tweaked. Overall, I would say the quality is decent. It's not comparable to what I'm getting in the production pipeline with the Gemini 3.6 Flash model, or even the previous ones, but it's fairly reasonable overall. Let me pull up the Markdown preview. That's a bit nicer, right? So we now see we have the full newsletter post here. We have the signal. We have an article citation in here, the problem, the solution. So it's correctly following the exact structure that I specified for the newsletter. We have the business case, which consists of the revenue model and go-to-market strategy. There's some numbers in here as well. There's a mode, schema stickiness. Okay. And yeah, why now? And then finally, the builder's corner. It suggests fast API with Python, Neo4j for the graph relationships, PostgreSQL. So this all looks pretty reasonable to me. Let me briefly open up LM Studio again. So here we see the two models that I'm using. Again, we use the smaller E4B model for triage and extraction, and then the 12B model, and specifically the quantization-aware version of it for the more sophisticated pipeline steps. And the two changes I made were temperature is a big one, and actually this is something that I've bumped into in previous local AI experiments as well. So temperature basically controls how much randomness the LLM will inject, right? Like the tooltip says here, with temperature at 0, you would always get exactly the same result. That wouldn't be very creative or exciting. So dialing it up adds more creativity so you can get different, more varied outputs. The default is 1.0, but with local models, at least with the lower end ones, that often means that they bump into problems where maybe they cut off the response prematurely, or they don't successfully return the right JSON schema or something like that. I have it at 0.35 right now. That seems to be a pretty decent sweet spot. You can play with it. I think in the past, I've even gone down to like 0.2 with some other experiments. So see what works best for your use case. And then the second change, I haven't conclusively experimented with this, but I very, very slightly tweaked the top P sampling here from 0.95 to 0.9. So the tooltip here says, minimum cumulative probability for the possible next tokens acts similarly to temperature. So they're kind of related. So that works okay. I'm sure there's a lot of other permutations you can try out that might work even better. But yeah, with these settings, the pipeline actually completes just fine. Again, it's just the text-based steps right now. So we get the newsletter markdown. We also get the podcast script. And it also generated the image prompt. But of course, the actual image itself was generated by Gemini, so Nano Banana, basically. But all of these would be pretty straightforward to replace with local models as well. I'm actually going to commit all these changes to GitHub as well. So if you want to play with it, just grab the latest version of the repository there and then, tweak it as you see fit. But yeah, that's all I wanted to cover. So unscripted. Sorry if this was a little bit rocky, but hopefully interesting nonetheless. Let me know in the comments if you want to see more of this or less of this for that matter. Like and subscribe, and see you in the next one. Thank you.